This is a sampling of problems for the second midterm. Problem 1, find the local minimum or minima and the local maximum or maxima of the function f of x equals x to the third minus 3x squared minus 24x plus 2. So our first step is to take the derivative and then set the derivative equal to 0. So the derivative of this function is f prime of x equals 3x squared minus 6x minus 24. Setting that equal to 0. We now want to solve for x in this quadratic polynomial. There are a couple ways to do it. We could graph and find the x-intercepts, or this polynomial is factorable. So to factor it, we would pull out a 3, and then factor what remains. This factors to x minus 4 times x plus 2. And then we solve. This first factor gives x minus 4 equals 0. So x equals 4. The second factor gives x plus 2 equals 0. So x equals negative 2. Now we want to check those two critical points to determine if either of them are minimums or maximums. So we check on a number line. I'm going to put negative 2 and 4, the critical numbers, on the number line. And then we're going to check a number on either side here. So we could check negative 3 on this side, 0 in the middle, and 5 on this side. We're going to plug those numbers into the first derivative. And I'm going to plug in to the first derivative the factored form, because all we need is the sign of the derivative at each of these points. So f prime of negative 3 is 3 times negative 3 minus 4 times negative 3 plus 2, which is 3 times negative 7 times negative 1, which is positive 21, where really we only care about the positive sign there. Plugging in 0, get 3 times 0 minus 4 times 0 plus 2, which is 3 times negative 4 times 2, which is negative 24. And then f prime of 5, which is 3 times 5 minus 4 times 5 plus 2. So 3 times 1 times 7, which is positive 21. So now the signs of our first derivatives at these numbers tells us that approaching negative 2 from the left, we have a positive slope or positive first derivative. And then after negative 2, we have a negative first derivative or negative slope. That means we have a local max at x equals negative 2. And then at 4, we have a negative first derivative to the left of 4 and a positive to the right, which means that we have a local min at x equals 4. So our last step is to find the values, the local maximum and local minimum values. So starting with x equals -2, let's now plug into the original function. So f of -2 is equal to -2 to the third minus 3 times -2 squared minus 24 times -2 plus 2. We get that f of -2 is equal to 30, which means that we have a local max of 30 at x equals -2. Now we plug in 4 to the original function. F of 4 is 4 to the third minus 3 times 4 squared minus 24 times 4 plus 2. We get f of 4 equals -78, which means we have a local min of -78 attained at x equals 4. So local max of 30 at x equals -2, local min of -78 at x equals 4. Problem 2, the cost of producing x widgets is given by c of x equals 0.2x to the third minus 6x squared plus 165x. Find the production level that gives the lowest average cost per wheel. What is the minimum average cost? So since we're given cost and we're looking for average cost, that means for lowest average cost, we're going to minimize the function c bar of x. And to get the function c bar of x, we take our cost function and divide by x. So 0.2x to the third over x minus 6x squared over x plus 165x over x. So our c bar function is equal to 0.2x squared minus 6x plus 165. To minimize this function, we take the derivative. C bar prime of x is equal to 0.4x minus 6 plus 0. And solving this function, set equal to 0, we would add 6 to both sides. And then divide by 0.4. This gives that our number of widgets is 15. Right now we only know that that's a critical point. Let's make sure that it is a minimum since we're trying to minimize cost. So on a number line, put 15 and then a number either side, so 0 and 20. If we plug in 0 to this c bar function, that would be 0.4 times 0 minus 6, so -6, so on this side of 15 we're negative. Plug in 20, that would be 0.4 times 20, which is 8, minus 6, which is 2, so we get positive here. That means that the derivative approaching 15 from the left is negative, and then at 15 the derivative changes to positive, so we do indeed have a minimum value, a local minimum value at 15. Now let's find the minimum average cost. To find that, we're going to plug in our 15 into the C-bar function, because we want to know the average cost that goes with this minimum x value. So we want to find C-bar of 15, which would be 0.2 times 15 squared minus 6 times 15 plus 165. The minimum average cost will be $120. So the minimum average cost is $120, and it's occurring when 15 widgets are produced. Problem 3, find dy dx at the point 2, 1 of the equation negative y to the fourth plus y squared minus 3x equals 2x squared plus y. So first we take the derivative. Remember, this is implicit differentiation. So that would be negative 4 y to the third dy dx plus 2y dy dx minus 3 equals 4x plus the derivative of y is just dy dx. And now we want to solve for dy dx, but since we have a number value to plug in for x and y, we can do that first now that we have taken the derivative. So plug in 2 for each x and 1 for each y. That would be negative 4 times 1 cubed dy dx plus 2 times 1 dy dx minus 3 equals 4 times 2 plus dy dx. Simplifying this, we get negative 4 dy dx plus 2 dy dx minus 3 equals 8 plus dy dx. Okay, now I'm going to move all of the dy dx's, I'll write this as 1 dy dx over to the left and all of the numbers over to the right. So I'm going to add 3 to this side, subtract 1 dy dx from this side. That's going to give us negative 4 plus 2 minus 1 is negative 3 dy dx. And then to solve for dy dx, we would divide by negative 3. So our final answer is that dy dx is equal to negative 11 thirds at this point.